Hi students, welcome to my channel Thoughts of Physics.
In the video series of ray optics, in this class I am going to explain compound microscope and the expression for the magnifying power, or it is also called as magnification of compound microscope. The magnifying power denoted by M. So first, what is compound microscope? So compound microscope is an optical instrument. It is used to observe the highly magnified images of tiny objects. Tiny objects means small objects. Compound microscope is an optical instrument used to observe the highly magnified images of tiny objects. Now this compound microscope, it consists of two convex lenses, converging lenses. The two convex lenses, or the first one is objective lens or objective. It is denoted by O. O means objective. So this objective lens, it has small focal length and small aperture. The focal length of this objective is small and aperture also small. What is this aperture means? The effective area available for the light to incident on the lens. The effective area available for the light to incident on the lens. That is aperture. Now the second lens of this compound microscope is called eyepiece. It is denoted by E. So this eyepiece has the moderate focal length, that is medium focal length, and large aperture, area of aperture, large area of aperture. Now these two lenses, that is objective and eyepiece, both held coaxially at the free ends of a tube at a suitable distance from each other. These two lenses held coaxially along the same axis at the free ends of a tube at a suitable distance from each other. So now let us draw the ray diagram for the image formation of this compound microscope, and let us determine the expression for the magnifying power of this compound microscope. So this is the ray diagram of image formation by the compound microscope. Let us explain this diagram here. Now this is a convex lens. Already we have discussed that a compound microscope consists of two convex lenses. So this is a convex lens which is O. O means objective. This is another convex lens E, that is eyepiece. Already we have discussed that objective have small focal length and small aperture. Eyepiece has moderate focal length and large aperture. Now let us consider an object AB. AB is the object. The height of the object is HO. Height of the object is HO. An object is placed beyond the principal focus of the objective. FO is the principal focus, first principal focus of the objective. Here this FO is the second principal focus of the objective. Any lens have two focal points, first principal focus, second principal focus. So this is FO is the first principal focus of the object. Now the object is placed beyond the principal focus. That means object distance U is greater than the focal length. Object distance is greater than the focal length. Whenever the object distance is greater than the focal length, the lens forms real and inverted image. Real and inverted image. Now here HI. So now here to form this image we need to consider minimum two light rays. A light ray which is parallel to the principal axis. This is the light ray parallel to the principal axis. Now a light ray parallel to the principal axis, after refraction it passes through the principal focus FO, second principal focus. Now this is the light ray parallel to the principal axis, and after refraction it passes through the principal focus. This is the light ray. And the second light ray here we consider, that is a light ray passing through the optic center. A light ray passing through the optic center, it does not deviate. It passes along the same direction. Now this is a light ray passing through the optic center. It does not deviate and it moves along the same direction. Now the point where the two light rays meet, there it forms the image. The objective forms the image. Now A dash B dash is the image formed by this objective. A dash B dash is the image formed by this object. Here FE is the principal focus of the eyepiece. FE is the principal focus of the first principal focus of the eyepiece. And the distance from its optic center to the principal focus is called the focal length of the eyepiece. Small FE is the focal length of the eyepiece. Small FO is the focal length of the objective. Small FE is the focal length of the eyepiece. Small letters means focal lengths. Capital letters means principal focal for both eyepiece as well as objective. Now, here this A dash B dash is the image formed by this objective. Real and inverted image, because object is placed at a distance greater than the focal length. Now, here the distance between these two lenses adjusted such that the image formed by this objective formed below the principal focus of this eyepiece. That means this image formed just below the principal focus. It is formed between optic center and the principal focus. That means this image, it acts as object for this eyepiece. The image formed by this objective lens acts as object for this eyepiece. Now, this object for this eyepiece is at a distance less than the focal length, because it is formed between optic center and principal focus. That means here the object for this eyepiece HI, that is A dash B dash, it is formed at a distance less than the focal length. When the object is at a distance less than the focal length, it forms virtual and erect enlarged image. Whenever the object distance is less than the focal length, it forms virtual image, enlarged image, and erect image. Now this A double dash B double dash is the final image formed by the combination. That means final image formed by this eyepiece. Now the object is AB and final image is A double dash B double dash. The height of the object is HO. Height of the image formed by this object is HI. Now this is the ray diagram for this compound microscope image formation. Now here FO is the focal length of the objective, U is the object distance for this objective, FO already we have discussed the focal length of this objective. L is the tube length. L is the tube length. So what is tube length means? The distance between second principal focus of the objective and the first principal focus of the eyepiece. The distance between second principal focus of the objective and the first principal focus of the eyepiece, that is the distance between FO and FE, is called L. The L is called the tube length. L is called tube length. Now we have considered here angles beta. These are the symmetric triangles. Symmetric triangles. From this, with the help of these triangles only, now we are going to find the magnification. Now, here let us consider the triangles. The triangles are here. Now, the triangles A dash B dash FO. Triangle A dash B dash FO is one triangle. A dash B dash FO one triangle, and OPFO another triangle, and triangle OPFO are similar. The triangles A dash B dash FO and OPFO are similar triangles. We know for the similar triangles the ratio of sides equal to ratio of bases. In the previous concepts also we have applied this formula. Ratio of sides is equal to ratio of bases. Now let us apply the formula here. Then what we will get, let us see. Now let us apply the formula for the first triangle A dash B dash FO. For this A dash B dash FO triangle, Now I have taken this side, that is A dash B dash is a side. Its length is HI. Now HI by, it's a similar triangle is OPFO. OPFO. For this OPFO triangle, the side which is similar to HI is OP. So OP length is HO. HO and OP both are same because that light ray is parallel to the principal axis. So that's why now HI by you can take HO. This is for this triangle A dash B dash FO HI. For OPFO the side is similar side is HO. HI by HO. That is equal to this ratio is equal to the ratio of bases. Now A dash B dash FO triangle, the base is this one, that is L. L by its similar triangle is OPFO. Now the length which is similar to L is OFO. That is nothing but focal length FO. L by FO. So already we know that the ratio of height of the image to the height of the object is called the magnification or magnifying power. That can be taken as, let us say, M. Let it be equation number 1. Equation number 1. Next, let us consider the triangles, that is angles there. For these same triangles only, let us consider the angles. Now for this triangle, what is that? A dash B dash FO. For this triangle, let us take tan beta. Tan beta is equal to, and these triangles. Next, another triangle OPFO. OPFO. The two triangles I am taking tan betas. For this triangle, if you take beta, tan beta, the formula of tan beta is opposite side by adjacent side. For this beta, opposite side is HI. HI by, for this beta, adjacent side is L. HI by L. That is equal to, now, next take this beta. That is, what is that? OPFO, the triangle. Now, if you apply the tan beta here, opposite side is OP. OP is nothing but HO. HO by adjacent side this for this beta is OFO. OFO is nothing but FO. Focal length FO. Now, if you write this, rearranging the terms from this HI by HO, I am taking HO denominator. That is HI by HO is equal to L by F naught. You will get. Let it be equation number 2. Now, HI by HO, equation number 1 is HI by HO is equal to L by F naught. Equation number 2, HI by HO is equal to L by F naught only. That means here it is the M. M is what here? MO, the magnification due to objective. Now, here HI is the image formed by this object. MO is the magnification due to objective. Now, from the first and the second equations, you can write MO is equal to, that is magnification produced by the objective, that is equal to, what is that? That is L by FO. From the first and second equation, MO. MO is nothing but the magnification produced by objective. Now, the objective, we have completed the magnification. Next, the magnification produced by eyepiece we have to consider next. The magnification produced by eyepiece means this is the object, the image formed by this objective, it acts as object for this eyepiece. Now here, the object for this eyepiece, it is between optic center and principal focus at a distance less than focal length. Now, it forms virtual and erect enlarged image. So, image formed by this is, that is A double dash, B double dash. That is the final image. Now, it is nothing but a simple, in case of simple microscope, already we have discussed that when the object is placed at a distance less than focal length, it forms erect, virtual and enlarged image. Now, this second case is nothing but simple microscope case. Now, the magnification due to this eyepiece is nothing but the magnifying power due to simple microscope. The magnification due to this eyepiece is nothing but the magnification due to simple microscope. So, for time being, let us consider the final image A double dash, B double dash. The distance between objective and eyepiece adjusted such that the final image is formed at a distance of let us consider capital D. The final image formed at least distance of distinct vision. That means at near point, D is for least distance of distinct point. That is, the final image A double dash B double dash is formed at capital D. Let us consider. The magnification due to eyepiece is the magnification due to simple microscope. That when the image formed at capital D. Now, when the image formed at capital D, when the image formed at capital D, the magnification due to eyepiece. Already we have discussed that the magnification due to eyepiece is nothing but magnification due to simple microscope, because this case is nothing but simple microscope. That's why the magnification due to eyepiece can be taken as ME. That is equal to, already we know, when the image formed at capital D, near point, the magnification formula 1 plus D by F. Now here FE. FE is the focal length of the eyepiece. D is the near point. Now this is the magnification produced by the eyepiece. MO is the magnification produced by the objective. ME is the magnification produced by eyepiece, because eyepiece acts as simple microscope. So we have taken simple microscope formula when the object is formed at D, that is near point. Now, if the image formed at infinity, we know the magnification formula 1 less than the image formed at near point. So the magnification due to eyepiece becomes ME is equal to D by FE. This is 1 less when it is formed at infinity. Why we consider the image formed at infinity means, when the image formed at infinity, without straining the eye, we can observe the image with a unstrained eye, with a relaxed eye, we can say. Then the total magnification M can be written as the product of magnification due to objective and the magnification due to eyepiece. That is MO into ME, the product of the two magnifications. That is equal to, already the magnification due to objective is, we have calculated MO is L by FO. Here L is the tube length, FO is the focal length of the objective. ME is the image formed at infinity means D by FE. That is, D is the least distance of distinct vision and FE is the focal length of the eyepiece. Now, this is the expression for the magnifying power of compound microscope or magnification of compound microscope.
If you have any doubts, you can ask in the comment section. For latest updates, subscribe and click the bell icon. Thank you.